Alrighty, so we're going to switch gears a little bit. We're still going to use the idea of stoichiometry, but this time we're going to identify which reactants is the limiting and the access reactants. And you've been hearing about limiting and access reactants throughout some of the labs and activities you've been doing the past couple weeks. So now in a reaction, once one of the reactants is used up, no more products can be formed. Now, the reactant that runs out first in a reaction is called the limiting reaction, which is determined by how much product is produced. So when you make as many products as you can, and then all of a sudden one of your reactants runs out, that reactant will be your limiting. And the reactant that's not completely used up in the reaction, so there's leftovers, is called the access reactant. Now here are steps to determine the limiting reactants and the access reactants of a chemical reaction. So usually for these problems, you're going to be giving two data. You're going to be giving grams or moles of one of the reactants and grams or moles of the other reactant. So you're going to get two values. And you can convert both reactants values to moles of one product. So just pick one of the products and you're going to convert both of those values to the same mole product. And then the compound that produced the smallest from step one, so whatever two values are the smallest, is the limiting reactant. And the other reactant that's not limiting is your access reactant.
Okay, so let's go ahead and do some practice problems of finding the limiting and access reactants of chemical reactions. So we have this problem and it says if 6.3 moles of HCl reacts with 2.8 moles of CaOH2, what is the limiting and access reactant? And here's the chemical reaction we have. So what this first step says is we're going to convert each of what we're given to mole of one of these products. So let's go ahead and first circle what we're given. And what we are given is 6.3 moles of HCl, and we're given 2.8 moles of CaOH. And both of these are moles, so both of these types of equation or calculations, we're both going to be starting at mole-A's. Alrighty, so now, like I just said before, you're going to take each of these numbers and do two separate stoichiometry calculations to solve for moles of one of these products. You're converting both of these to the same product. So let's go ahead and do our 6.3 moles of HCl first. Now we need to go from mole A to mole B on your mole island sheet. It says that's mole ratio. Mole ratio is a conversion between compounds. So we got to take the compound we want to get to on the top, and the compound we want to get rid of is on the bottom. So we have HCl. We don't want that, so that's going to go on the bottom. And now we got to convert to one of these products. You can go to H2O or you can go to CaCl2. Let's do CaCl2, okay? So that's what we want to get to, so that's going to go on the top. Now remember, to get these numbers, we're going to look at the coefficient. So the coefficient in front of HCl is 2. And the coefficient in front of CaCl2 is 1. And the HCl's cancel, so we're left with moles of CaCl2, and that is what we want. So remember how you solve that is you multiply the top, divide the bottom. So when you do that, you get 3.15 moles of CaCl2. So now we got to do that idea again, but now with the 2.8 moles of CaOH2. Now we're given moles, and we want to find moles of the same compounds, the moles of CaCl2, and looking on the mole ratio, so if we're going from mole A to mole B, that's this mole ratio, and that is a conversion between compounds. So the compound we want to get to is on the top, and the compound we want to get rid of is on the bottom. Since we have CaOH2 and we do not want that, that's going to go on the bottom. And the compound we want to get to is CaCl2. And then let's look at get these numbers. They're the coefficients. So the coefficient in front of CaOH2 is 1. And the coefficient in front of CaCl2 is 1. So our CaOHs are canceled. We want moles of Cl2. And then let's go ahead and calculate that. And that is 2.8 moles of CaCl2. All right, next up is we got to figure out which of these two answers we got is the smallest. So looking at them, we have 3.15, 2.8. 2.8 is the smallest, and what produced 2.8 is the CaOH2, that reactant, and that's your limiting. So your limiting is CaOH2. Since CaOH2s are limiting, the other reactant, HCl, is going to be your excess. And that is your answer. So let's go ahead and do another one of these examples. And this time we have if 3.17 grams of Al reacts with 2.55 grams of O2, what is the limiting and excess reactant? And here's our chemical reaction we're going to need. First step always is to circle what we're given. Well, we're given 3.17 grams of Al and 2.55 grams of O2. And looking at our molecular sheet, we have grams of a compound. So we're going to start at mass A, as well as over here mass A. So now we got to do two separate stoichiometry problems. One for this information and the other one for that information, and we got to convert to moles of one product. Well, since we only have one product here, we got to convert both of these information to moles of that. So we get two separate answers for that product. So let's go ahead and start with the 3.17 grams of Al. So we got to go grams of one compound to moles of another compound, okay? So when you look at your molecular sheet, that is two steps. We got to go from mass A to mole A, and then we got to go mole A to mole B. So our first step from mass A to mole B, what's on the top is 1 mole, and what's on the bottom is molar mass. And we got to find the molar mass of Al, since that's what we have in the calculation. And the mass of Al is pretty much just the atomic mass of aluminum, which I believe is, let's see, is 26.98, and that's going to go on the bottom. And then what cancel out is our grams, and what we're left with is moles of Al. We don't want moles of Al, we want moles of our product. So we're going to do one more step. So we just ended at mole A, now we have to get to mole B, and that step is mole ratio, conversion between compounds. The compound we want to get to is on the top, and the compound we want to get rid of is on the bottom. We have Al, we do not want Al, so it's going to go on the bottom. And we want to get to Al2O3, so that's going to go on the top. So now we got to find these coefficients, okay? So we have to look on our chemical reactions. So Al is here. Al has a coefficient of 4. Al2O3, coefficient of 2. And what cancels that step is Al. And what we're left with is moles of Al2O3, and that's what we want. So we can go ahead and calculate that. Again, two ways to do that is multiply, divide, or multiply all the tops, multiply all the bottoms, and you can divide those two numbers. So let's go ahead and do that calculation. And what you get is 0.058747 moles of Al2O3. Okay, so now we got to do that calculation again, but this time with our 2.5 grams of O2. Let's go ahead and do that. Now we have grams of one compound. We want to get to moles of our product. So again, that's two steps again. We got to go from mass A to mole A to mole B. And so we have to do our first step, which is mass A to mole B. And when you look at your mole rate, your mole island sheet, 1 mole is on the top and molar mass is on the bottom. So we have a molar mass of, we have to find the molar mass of O2 since that's the compound we have in the calculation. So let's go ahead and do that. On the periodic table, the atomic mass of oxygen is 16. We have 2 of them, so we multiply that over by 2. And when you plug that into the calculator, you get 32 grams per mole, and that goes on the bottom. And what happens in this step is your grams are canceled. What you're left with is moles of O2, but we don't want that. We want moles of Al2O3, so we got to do one more step. So we just ended in mole A. We want to get to mole B. That step is mole ratio. Remember, conversion between compounds. The compound you want to get to is on the top, and the compound you want to get rid of is on the bottom. So we have O2. We don't want O2, so that's going to go on the bottom. And we want to get to Al2O3, so that goes on the top. So looking at those coefficients, looking at that reaction, coefficient for O2 is 3. And coefficient for Al2O3 is 2. And what cancels out is our O2s. And now we're left with moles of Al2O3, and that's what we want. So we can go ahead and start calculating that. And when you do, you get 0.053125 moles of Al2O3. So now we got to figure out of these two answers, which one's the smallest? We got 0.058747, or we got 0.053125. Well, the 53125 is the smallest, and the reactant that produced this number is O2, so our limiting reactant, is O2. So the other reactant of O2 is Al, and Al will be your excess. And that is your answer. Okay, so let's go ahead and do one more problems of finding limiting access reactant. So in this one we have if 36.0 grams of H2O reacts with 67 grams of Fe. What is a limiting access reactant? And here's the chemical reaction we're going to need. First step, always circle what we're given. We're given 36 grams of H2O and 67.0 grams of Fe. Now, since we're doing two separate stoichiometry calculations with these numbers, we know this is mass of one compound, so we're going to start with mass A. And this is also grams of one compound, so this is also going to start at mass A. So now we have to go ahead and do our stoichiometry calculations, two of them. The first one, what we're going to start with, is our 36 grams of H2O. Again, when we go ahead and do this, we got to go grams of, we have mass A, and we need to convert to a mole B of one of these products. We can pick whatever one we want. So if we're going from mass A to mole B, that's two steps. We got to go from mass A to mole A to mole B. So let's go ahead and focus on the mass A to mole A. When you look on the mole island sheet, it says that 1 mole is on the top and molar mass is on the bottom. And we got to find the molar mass of a compound we have in the calculation, which is H2O. So let's go ahead and find the molar mass of that compound. So looking on the periodic table, the atomic mass of hydrogen is 1.01. And we have 2 of them in the compound. The atomic mass of oxygen, according to the periodic table, is 16. And we have 1 of them in the compound. So when you plug that in, we get 18.02. And that goes on the bottom. So in that step, our grams are canceled. And what we're left with is moles of H2O. Well, we need moles of one of these products, so we got to continue on. So we just ended at mole A. Now we got to go to mole B. And on our mole ratio, on our mole island sheet says mole ratio, and that's a conversion between compounds. So we got to figure out what compound we want to get to is on the top, and what compound we want to get rid of is on the bottom. We have H2O. We don't want it, so it's going to go on the bottom. And we want to get to one of these products. So I can either do Fe3O4 or H2. Let's go to H2. So now we got to look for our numbers, which is the coefficient in the chemical reaction. So H2 has a coefficient of 4. H2 has a coefficient of 4, and H2 has also a coefficient of 4. So what cancels is our H2O. And what we're left with is moles of H2, and that's what we want. So we can go ahead and start calculating that. Again, to do that, you'll multiply the top, divide the bottom, multiply the top, divide the bottom, or you can multiply all the tops and then multiply all the bottoms, and then you can divide those two numbers. So let's go ahead and do that. And when you do that, you get 1.99778 moles of H2. So now we got to do that stoichiometry calculation again, but now we have 67.0 grams of Fe. So let's go ahead and do that. So we are given grams of one compound, so we start at mass A. And again, we want to convert to the same product we converted in our past one, which is H2, so we want to get to moles of H2. So we have to go from mass A to mole B, and when you look at your mole island sheet, that's 2 steps. So we got to go from mass A to mole A to mole B. So let's go ahead and look at our first step, which is mass A to mole A. And on your mole island sheet, that step says that 1 mole is on the top and molar mass is on the bottom. So we got to find the molar mass of the compound we have in our calculation, which is Fe. Well, Fe is a single element, so that's the molar mass is the atomic mass. So the atomic mass of Fe on the periodic table is 55.85 grams. Okay, and our grams cancel out on that step, so what we're left with is moles of Fe, and we want to get to moles of H2, so we got to continue on. Now we just ended at mole A, we need to get to mole B. On your mole island sheet, that step says mole ratio, so it's a conversion between compounds. The compound we want to get to is on the top, and the compound we want to get rid of is on the bottom. We have Fe, we don't want it, so it's going to go on the bottom. And we want to get to H2, so H2 is going to go on the top. So now we got to look for these numbers, which is our coefficients. So the coefficient for Fe is 3. And the coefficient for H2 is 4. And what cancels here is our Fe. And what we're left with is moles of H2, and that's what we want. So we can go ahead and start calculating that. So when you do that, you get 1.599952 moles of H2. So now we got to figure out which of these two are the smallest, okay? We got 1.99778, 1.59952. Well, the 1.5952 is the smallest. So the reactant that started that number is Fe, so Fe is our limiting. And the other reactant besides Fe, which is H2 will be our excess then. H2O will be our excess then. And that is your final answer.